Hello everyone. In this video, we're going to begin our discussion of programming languages. Specifically, we're going to talk about the difference between low-level languages and high-level languages and how we can utilize high-level languages in order to write a program that our computer can execute. So let's take a look at today's notes and our learning objectives. So we're going to talk about high-level versus low-level and the details of entering, translating, and running a high-level language. So we've got a warm-up task here, a little bit bigger than our last couple warm-up tasks. So what we'll want to do is cd into our CPSC 121 directory we made in the previous video, and we'll want to create a file called helloworld.cpp using gedit. And in gedit, we'll type this code. And note that this code needs to be typed exactly. Make sure you have all of the same capitalization, spacing, use of symbols, etc. This is our first C++ program. We're not going to get around to compiling and running it in this video, but we will in the next video. But it's good to get a little bit of practice working with gedit and starting to type out some code. Even though we may not know exactly what this code means at this point, we will soon. So go ahead and take a stab at this warm-up task. Pause the video and I will check in with you here shortly. So I'm in the CPSC 121 directory and I am going to make a file called helloworld.cpp using gedit. So helloworld.cpp, that probably sounds kind of strange, right? Well, typically, convention is in programming that the first time you are writing a program in a new language, you'll just display hello world to the user. Very simple program, but it's just kind of convention and it's kind of fun that you always say hello world. Now, we've been working with .txt files so far when we learned about Linux commands, but this isn't a .txt file, it's a .cpp file. Well, the CPP part stands for C++, which is the programming language that we're going to use in this class. Even though it's a .cpp file, it looks exactly like a text file. The .cpp part is mostly used in order to determine what types of programs can open this. For example, gedit can open it, and it's also used for us as programmers to help us see, okay, this is a C++ file versus this is a text file, etc. But don't be too overwhelmed with helloworld.cpp. Like I said, we don't know exactly what this code looks like or what it does or the details of it, but that's why you're taking this class, is to learn that. I just want to get your feet a little wet, starting to write some code and see just what it looks like. So go ahead and type that code out as exactly as you can get it, and then save your file. Control S or hit save up here. While we've got gedit open, I want to show you some preferences that you should set in order to make programming a little bit easier for you. If you go up to the right of save, there's a button that looks like 3 horizontal lines. Usually it's called a menu or a hamburger icon. Click on that and click on preferences in the context menu. Make sure that you have the first checkbox selected to display line numbers. That's what you're seeing over here on the left. These aren't actually part of the code or anything that we typed or can type. They'll just be there every time you make a new line, as you can see. Those are really helpful. Definitely turn those on. Some other settings that you might want to match mine. Enable text wrapping. That's so you don't have to horizontally scroll. Do not split words over 2 lines. And these last two for highlighting are especially important. Highlight current line and highlight matching brackets. So the highlight current line helps you find your cursor really easily, and then the matching curly brackets, for example. If I click on this one, it shows me there's a matching one down here. Same with parentheses. So those are really helpful to set. If you go over to the Editor tab, you don't need to change too much here. I like enable automatic indentation. Autosave files, you can if you want, that's up to you. I do not recommend selecting create a backup copy of files because then when you do ls, you'll start to see all these weird tilde backup files, and they're not really that helpful in my opinion. Fonts and colors, if you would like, go ahead and try out some fun different color schemes. I'm going to stick with classic just because I know it's easier to read on a projector. So I'll stick with classic, but you're all free to have some fun with some of these other ones. All right, so we've got our code typed up. We're not going to actually run this code at this point. We will next video. So just kind of keep your hello world.cpp file here and hang tight. We're going to shift our discussion now into learning a little bit more about what is the C++ programming language and how does it fit into this broader notion of programming languages in general. So right now, you're understanding what I'm saying because I'm speaking English and you know how to read and interpret and hear English. We have some kind of mutual contract between us, right? If we both speak and understand English, then we can communicate. So English is an example of something called a natural language. There's a lot of different natural languages, English, Spanish, Portuguese, etc. English is just one of them. Now, natural languages are very, 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 very far from what a computer or a machine can understand. Inside of your computer, you have something called a CPU, a central processing unit. And CPUs actually only know how to interpret zeros and ones, which is called binary. Some of you have probably heard of binary before. Some of you have not. It's okay. We're not going to work with binary. It's very, 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 very low level, very actually difficult to work with because our mind doesn't quite work well in zeros and ones. It works better in terms of words and syntax and grammar. So if humans aren't very good at speaking binary, but computers only know binary, how do we get from here to here so that we can effectively tell our computer what to do? That's where programming languages come in. We can write code close to English that will be translated by a program into binary so that our computer knows what we're trying to tell it to do in our program. So I'm going to go ahead and kind of fill in a little bit more of this diagram so you can see a different, so you can see a spectrum of the different types of programming languages. So machine language runs on hardware. We write software so that we can run our programs on the hardware. But between hardware and our natural languages over here, we have this spectrum of programming languages. And the ones that are closer to the natural language side, we call these high-level programming languages. High level is in they're high, they're far away from hardware, and they're close to natural language. Then over closer to hardware, or lower to the hardware, we have low-level programming languages. There are hundreds of programming languages. Just like there are hundreds or thousands of natural languages, there are lots of programming languages. Some are more popular than others. Some are designed for a specific task or a specific purpose. Some are really good at, for example, parallelization or matrix computation, modeling, visualization, etc. What you're trying to solve usually will indicate what kind of programming language you should use. Typically, we'll work in the field of general purpose programming languages. These are the most popular because they're so large and I'll say old. They've been around for a while that there's a lot of code already written. There's a lot of people who support it. There's a lot of documentation online, a lot of help. And that's what's kind of made general purpose programming languages so popular, is if you learn one, you can typically use it to solve a variety of problems. Whereas some of the other more specific programming languages, you learn one and maybe it's really well suited for one problem, but when you go to solve a new problem, you might need to use a different programming language. It really depends on the context. We're just trying to get kind of a high-level overview here. So we've got our low-level and our high-level programming languages, and I'm going to list some of the general-purpose programming languages, and you might be surprised that you might recognize some of them. For example, the number one most popular programming language in the world is Java. You've probably heard of Java. Typically on your computer, you'll get this message that says something like, Java needs to be updated, Java's not installed, Java applet, etc. Java. That is the number one programming language in the world for several reasons. One is this is actually what the Android operating system is written in. Another programming language right around here is C++, which is a top 4 programming language in the world. Depending on who you ask, I won't give specific 2, 3, or 4, but it's a top 4. And that's the programming language that we're going to use in this class. Now, slightly above, perhaps Java and C++, would be a language called Python, which is my favorite programming language. It's really good for beginners to use, and it's very general purpose. Slightly below Java and C++, I would say, is a programming language called C. Now, C is much older than C++. C++ is actually an improvement or an object-oriented improvement to C. Later in the semester, you'll learn about the plus plus operator and see that this is actually a funny joke, C and C++. But until then, just think of this as just an improvement over C. But C is also a top 4 programming language in the world. It's used in a lot of hardware because it's been around for a long time, and it's getting a little bit closer to the hardware layer. Now I'll just add one more in here. Pretty close down here to hardware is something called assembly language. This is not quite zeros and ones. There are some human words used in assembly language, but it's very primitive. You would not write any large-scale software in assembly if you could avoid it. So this is just a high-level overview of some of the programming languages. Other ones you might have heard of include JavaScript, Ruby, Perl, Pascal, COBOL, Haskell, etc. There are a lot of them out there. If you want to learn more, you can just do a search for programming languages and see all the different types and all the different languages and what they're good for, who designed them, when, etc. So now that we've got kind of this spectrum and we see a little bit in where C++ fits low versus high level, let's talk a little bit more about this translation process. So we write code in a high-level programming language like C++. But remember, our computer, our CPU, cannot directly run a high-level programming language code. It can only run binary. So how do we get this C++ code that we've written in English? And here's an example of C++ code right here. How do we get that into zeros and ones? So that brings us to our next diagram we're going to draw, which represents the translation, the compiling, the linking, the loading, and the running process. So we've invested a lot of time so far already just learning the just learning the Linux commands such as cd, gedit, touch, move, copy, pwd, ls, etc., so that we could essentially execute commands from the command line that will start this translation process and run our program. So there's a little bit more details to it than that, but we're going to draw a high-level diagram of it. So when we do start to write the Linux commands, execute the Linux commands, it will make a little bit more sense in terms of the bigger picture. So let's start with the idea of editing a program. So we'll use a program like gedit to edit a C++ source file. So this typically gives us a .cpp source file that contains our program. Now, just to make these look a little bit different, anytime we're dealing with a program, I'll put a red box around it. So gedit is a program that we use to edit code which represents a program. It is not a program itself. It cannot be executed on your machine. In order to execute this source code as a program, we have to make it into a program, which brings us to our next step. We use the G++ compiler to translate a CPP source file into object code, which is kind of a fancy way of saying machine code. So G++ is a program. We can actually execute it at our terminal, and it's a compiler. And the idea behind a compiler is it accepts as input a source file, and it translates it into machine code and produces an output file. Which has an extension of .o. Now, you would think, okay, now we've got this .o file, it's binary, we can run it. Not quite. That's why I said there's a little bit more details to this than initially meets the eye. So this .o file is not an executable program. And those of you who are coming from a Windows background, quick way that I can describe to you an actual executable file would be a .exe file. That's something that you could double click and run on your computer. .o files we could not directly run on our computer. Instead, we take our .o file as well as other .o files from libraries. So this would be code that somebody else has written, some dependencies that our code has. And these serve as input to a program called the linker. The linker links or combines .o files into a single executable file, which could have almost any extension, but we'll call it a .out file because that's the default extension that our particular compiler G++ uses. So the linker is a program. We don't have to execute it explicitly. We can actually just use G++ in order to link our files together. But I do want to emphasize it's part of this processing pipeline because in the future, for more complicated programs you may be compiling, you may need to deal with the linker. Okay, so then the linker produces this .out file. And now this .out file is like an exe on a Windows machine that we can run. So in order to run this .out file, it is going to be input to a program called the loader, which loads an executable program into memory. And runs it. And now finally, our program is running. We'll see the command here to run our programs here shortly, perhaps in our next video. So one thing I want to add to this diagram is there could be another outcome from running our compiler on our source file other than making this .o file. So this assumes that the code is syntactically correct. Now earlier I mentioned that you should type the code exactly. Match capitalization, match spacing, match names, spelling, etc. Because if even one little tiny thing is wrong, the compiler is going to fail to make this .o file and give you a compiler error, which means you don't have a .o file. If you don't have a .o file, you can't link it to get a .out file and you can't run your program. So if this happens, you get an error. Don't worry, it's very standard. It happens all the time, all the time. And then you just come back to gedit. You edit it to fix the error. You save it to get your .cpp file on disk. And then you run g++, the compiler, again in order to try and get to this step where you successfully compile your program to get a .out file that you can run. So all of this seems very abstract right now, and it is because we haven't gone through any step further than essentially gedit, where we opened a hello world.cpp file, we typed some code, and then we saved it. So the next step would be taking that hello world.cpp file, sending it as input to the compiler via command line, typing g++ in the name of our file, and seeing, is it syntactically correct? Awesome. If it's not, okay, back to the drawing board essentially. Let's try and fix this. So that kind of brings us to where we're going to pick up in the next video. Some last things that I want to say in this video, however, about this whole process is it's not as complicated as it looks when we're going to use it in this class. Now, some of you may have some programming experience before where you weren't compiling and running your programs from the command line. Maybe you were using something called an IDE, which stands for an Integrated Development Environment, that essentially has a button, and you can click the button and it will do this whole process for you. Now, those are nice for large-scale projects, but you still need to know the intuition and the details behind what happens when you press that button. And that's what this diagram and this processing sequence of translating, compiling, linking, and loading will do for you. Another thing I want to mention is about how our programs run. So our programs in this class will all run in the terminal, which means that they are text output and they receive text input. Now that's somewhat basic, right? Perhaps, you're like, how can I build perhaps a program like gedit, or how can I build a program maybe like a mobile app or something like that? Those programs have graphical user interfaces, GUIs, which are pronounced as GUIs. In this class, we're not going to get to the point where we're going to program any GUIs. I know it's sad, I wish we did, but there's a lot to learn before we start coding up GUIs. So we're going to learn the fundamentals of programming using the C++ programming language. In the terminal, it'll be all text-based, but we can still build some very powerful programs. And then if you continue on in your programming education, perhaps you decide to major or minor in computer science, you will take a class, Computer Science 224, which is graphical user interface programming and event-driven programming that uses Java. So that is a great class to take if you want to get to the point where you learn how to make GUIs like programs that can run perhaps on Windows or on Mac, desktop, or on a mobile phone, or maybe you want to make a game that runs in the browser, for example. All sorts of those things you can learn, but you've got to walk before you run, and this class is where we learn that walking, all the fundamentals you need in order to build those more complicated programs.